Precision crop load management is a series of strategies to try to manage the number of apples on each tree to an exact number to obtain the best possible outcome. There's really three opportunities to influence fruit number per tree, and that's through pruning. Each time we cut off a branch, we're throwing some buds on the ground. Secondly, through chemical thinning, starting at bloom and carrying all the way on to 18 to 20 millimeters. And then lastly, by hand thinning. So the very first step is you have to establish a target of the number of fruits you want to harvest from each tree based upon fruit size and yield and on the potential that that orchard has in the particular climate that you live in. An orchard of tall spindle that is fully developed, the canopy is tall, 11 to 12 feet tall, fully filled in. That orchard could probably carry 1,200 bushels of Honeycrisp per acre at 80 count. And so at the spacing, which is 3 by 11, 1,320 trees to the acre, it should have 73 fruits. But the second orchard, because it's not filled in the upper part of the canopy as well, I said should only carry 800 bushels at 80 count fruit, same number of trees per acre, so it should carry only 48 fruits per tree. Then when we come to the thinning period, stepwise reduce the number of fruit through sequential applications using the pollen tube growth model first, then the carbohydrate model and the fruit growth rate model to guide post-bloom thinning sprays and determine whether we want to reapply any spray or not.
The NEWA 3.0 platform, NEWA, or the Network for Environment and Weather Applications, is made possible because it's part of New York State IPM. The Northeast Regional Climate Center is another key partner. So all the data we are actually using to inform these very useful models, it's all managed through a collaboration with that group. NEWA is a website format that is what we call responsive. So on your desktop, you're going to see something like is displayed on the left-hand side of your slide here. If you were to go onto your smart device or even a tablet, you're going to get a different experience. Everything is still available there. So when we're talking about the pollen tube growth model or carbohydrate thinning, on a phone, it's going to look a little bit different, and it's organized in such a way that all the features are still there. It just makes it easier to use on a smaller screen. So if you're on a smartphone and you want to use a model to access those important elements or functions on any given part of our website, you're going to see what we call the little hamburger menu in the upper left-hand corner. It's really important to remember this, because if you forget that's there, it's going to seem like the model is not working the way it should, and it could create some frustration. So just remember that. The other thing I want to point out is whether that is open or closed. On a smart device, it might be harder to see that there are actually scroll bars. So you can click and drag and move up and down through all the different parts of a given web page, however you normally would in a browser on your smartphone otherwise. In terms of recommended browsers, choose any one of these 4 popular browsers. I'm going to walk you right through from the beginning. When you go to newa.cornell.edu, this is the landing page. It basically showcases some of the features. With NEWA 3.0, if you sign up for a profile, those biofix data or pieces of data or information are going to be saved to a personal account that's secure. In the upper right-hand corner where that first arrow is, you'll see a sign-in link. And when you click on that, you'll get this pop-up. You'll go to sign up. You'll enter an email address, and you'll create a password that only you have. And then you click agree to NEWA data use policy. And that's pretty much it. There's some configuration steps after that, which you can review again through quick start tutorials on the knowledge base. Once you do that, you'll want to do a little bit of configuration. When you come in, you're going to be opened to your profile settings. The very first thing you want to do is add at least one favorite station. Now, the advantage to doing that is that if you look at a map of NEWA, you'll see that there are over 800 stations. By having a profile, you can select your favorite 1 or 2 or even up to 10 or whatever. And those will be the only ones that display across all of your different models. Here, I've selected Shoreham, Vermont, up on the Lake Champlain area. The next thing you want to do is click over to the NEWA Tools tab, which you'll see I've highlighted with an arrow, and then open up the Apple Tools dropdown and select Pollen Tube Growth Model. This gets you set up. Once you click on Dashboard, you simply click back, you'll see that now under favorite stations, you've got your selections available. So you'll see Shorten in the right-hand corner there. If you had more stations selected, those selected stations would show up in that dropdown. The other thing I'll point out, though, is we selected pollen tube growth model. And so now that model is available in your personalized dashboard at the bottom.
Bloom thinning in New York State. It's kind of something that more and more growers are looking to do. There's a lot of pros, right? You get larger fruit because you're thinning earlier and you have less competition during that cell division phase, right? When fruit size really can be increased by having more cells. A lot of our research has shown that you get greater return bloom when you do bloom thinning because we are preventing seeds from forming, and those seeds produce chemicals that inhibit flower buds. So we can help break some of the biennial bearing cycle by early thinning. Possible reduction in fungicide applications. We did some work with lime sulfur and regalia for that. And now we have this model, this what we call the pollen tube growth model, which allows for more precise applications. In the Eastern US, some of the reasons why it has not become a widely used practice is because of frost primarily. And the materials that we have for bloom thinning tend to be caustic and can cause things like russeting. Just a little reminder on apple flower anatomy. Here's our apple flower cross section. So what we're interested in for the pollen tube model is the green section here, right? This is the female part all the way down through the ovule here. This is where our pollen comes from. These are the anthers and the filaments. These are pollen source, that's the male. What we're interested in is when the pollen lands on the surface, and we'll look at it on the far right here of the anther, right? So pollen is dry, it has to hydrate, there's a lot of protein and some molecular reactions, and then it germinates and you get this pollen tube growing down through the flower. Here's the base of the style. Here's our ovary and our ovules inside the carpel, and the pollen tube needs to grow in there. And then the double fertilization event that happens, and then you have fertilization. The pollen tube growth model is measuring the time it takes from pollen to start growing on the top of the stigma all the way down to fertilization. So the style length is something that you have to measure in the field. And so we're measuring from the top of the stigma to kind of through the middle of the carpel there, almost down to the calyxes here. So not just the styles themselves, but down to the bottom there. And we figure that fertilization is probably happening somewhere in there where my pointer is. So we are measuring the starting point to the finish line. How long does that take to happen? And that's the pollen tube growth model. We generally go out and harvest a whole bunch of flowers, like 50, and measure them. And so this is just an example here of measuring. It can be measured with calipers. It can be measured with a little ruler, and then input an average of 50 styles. Now, the other big thing is to know when to start the clock. And so that's when the last king bloom flower that you want to be your crop for that year has opened. And then the first thinning spray happens when the pollen tubes have been modeled to grow beyond the average style is what you input. Okay, in other words, the flower at that point has been fertilized. And then additional thinning sprays are used to prevent fertilization. They have two different functions of measuring the pollen tube growth. The first is to allow a certain percentage of the flowers to get fertilized. And then the additional ones are to prevent any more fertilization to have happen.
To access the model itself, you click on Go to Tool. And then on the right-hand side of the screen here, we have what this will look like the first time you use it. You'll see there's not much there. So the first thing you want to do is you'll see that Create Block button. Click that, and you get another pop-up that says Create Block. So there's a few different things you want to enter here to get started. You want to enter a block name. The next is select your apple variety, average style length, and then you enter your start date and any subsequent spray dates. And then you click Create. So what happens here on the right-hand side is your preliminary display after you created a single block. On the left-hand side, you'll see that example 1 is now listed under blocks. And on the right-hand side, you'll see that there's a summary card or element called example 1 up at the top where I have an arrow. You'll see that it's got Honeycrisp selected, which is the apple variety I chose in that pop-up. And then it has an average style length of 13 millimeters, which is just an arbitrary number that I had entered to create this. If you ever want to go back to edit this block, you'll click over on the right-hand side of this card where it says Edit Block, and it'll open up that dialog again. We have several different elements available in this model. So right now I have growth graph selected and I have everything else turned off. If you want to turn more features on, you can turn as many on as you want. So on the right-hand side, what we have is a visualization of growth for this block that we've entered. The starting date that I provided was March 9th. Moving from left to right, you'll see an accumulation value. It goes beyond today's date, and that's because we provide forecasted hourly values. It does provide some estimate moving forward for planning purposes. We also have a growth table. And so what you'll see is I've turned off the growth graph on the left-hand side here and turned on growth table. It's simply a tabular representation of what we were just looking at in that growth graph. The final piece of this model is the hourly temperature graph. And again, this is just a visualization of what those hourly temperature trends are for the period of time that you're looking at. The next thing is how to add in your sprays. So I have opened the edit block, and now we see this card pop up. To enter your first spray, you simply select a date and actually an hour within that. Click update, and it's going to add your first spray. And you'll see that both in the graph and under the summary card in example 1, growth has been reset to 0 at whatever date and time you have selected there. In the graph on the 17th at 4 a.m., it resets and then immediately starts accumulating again. So this is one way to help you track through time. And again, we're going above 100% over there on the right because we're looking at predicted forecast values. In this last slide, I have created a second block, and it's exactly the same process. I have these side by side, however, to show you that they track independently. So if you create one block, it's going to look at weather variables independently of your second block. So you can completely customize these however you like. Example 1 has Honeycrisp. Example 2 has Golden Delicious. Example 1 has an average style length I entered of 12. Example 2 has 11, and so on and so forth. If you look at that summary list over on the left-hand side, you get an at-a-glance view of where your growth is at for each block independently.
So this is just kind of an example. So this is cumulative growth rate of the pollen tubes up to 111% of the style length, and then we put on a caustic material, and then we started the clock again, and then at 70%, we put a second spray on, and that would have prevented any more pollen tubes from reaching the base of the style and fertilizing the eggs. So we have models now for 7 cultivars. We're looking to add more. Here's our list here.
But starting with the petal fall spray and the succeeding sprays after petal fall, the carbon balance model becomes an important tool in deciding both when to spray and at what dose to spray. But after each spray, we use the fruit growth rate model to try to determine what happened with each of those sprays to guide whether or not we spray again. So it's possible in some years you might get all your thinning done with the blossom spray and the petal fall spray and stop. And the way that you judge that is through the use of the fruit growth rate model. In many other years, you have to spray again at 10 to 13 millimeters. And then in many years, that's enough. But in odd years, when thinners don't work so well, we have to come back in with a last spray at the 16 to 20 millimeter stage. I want to first start with just a review of the carbon balance model. This model was developed to help with thinning. It's based on 2 simple parts of the tree physiology. First, the photosynthesis process, which produces the carbon to support all growth functions of the tree, primarily defined by temperature and sunlight. The other side of the equation is really the uses of that carbohydrate, and that's dependent mostly on temperature. We have algorithms in this model that then distribute the carbon that's produced to the places that need the carbon, fruits, shoots, roots, trunk. Then we come up with a carbon balance, whether there's enough carbohydrate to support all the functions that the tree is doing, or there is a deficit, and we do this by day. I want to go through some of the particulars and some of the information that's contained in the carbohydrate model as you see it on NEWA. I also want to mention Pollyanna was able to produce a phone app where the same information from NEWA can be seen in a phone app called Malusim. It has a slightly different look to it, but the information on the phone app, Malusim, essentially comes from the NEWA website. When you click on the carbohydrate model, this is the landing page that you see. So the first thing is to pick the weather station. And you see here the station. I've selected Geneva, New York. You see, but also down here is this small toggle switch to select a different station. And so when you click on that button, you comes up with a map. And in this case, I picked the Geneva station so that when I run the model, it will use the weather data from the Geneva station. The second thing you need to do is to pick a date. I happen to pick June 10th from last year of 2021. That was near the end of the thinning window, just to show you what it looked like through the entire thinning period. So if you're looking at putting on a petal fall spray, it would be the date of petal fall. You have to choose or enter two dates, the date of green tip and the date of full bloom. Now, we hope that every grower will write these dates down for their orchard so that a few weeks later, when you need to run the carbohydrate balance, you can have those dates. The last thing that we incorporated into the model was how intense is the flowering. 75 to 100% of the spurs are flowering. That's intense flowering. If 50 to 75 are flowering, then that's more moderate flowering. If only 25 to 50% of the spurs are flowering, that's light flowering. And certainly below 25% of the spurs flowering, it's extremely light and would not warrant thinning. If you have a moderate to light bloom, often thinning response is much lighter. If you have an extremely heavy bloom, you get a greater thinning response. Once you enter that, the model will automatically calculate for you and will show you this page with a tabular form of the data and then a graphical representation of the last column of the data, which is the carbohydrate balance average. Now, I point out with the arrows important things that I think you should pay attention to when you use the model. Right here, I have this starting at green tip in 2021, which for Geneva was March 26th. The model will start based upon the green tip date that you put in as you started the model. And so this table, you can scroll through from green tip all the way down to today's date. It has the first two columns are maximum and minimum temperature. I've kept these columns in there for two reasons. First is there's long-standing pomological wisdom saying that temperatures above 80 degrees give much greater thinning. And so I want growers to pay attention when temperatures are high. The second pomological wisdom is that when nighttime temperatures are above 60 degrees at night, you get a lot more thinning. And so by looking at those temperatures, you can kind of get a sense of what's going to happen. But what's not built into pomological knowledge is the third column, which is solar radiation. It's in a scale called megajoules per square meter, and that scale goes basically from a very low 2 to 3 to 4 number up to about 30. So intense sunlight in New York is about 30 megajoules per square meter. And you can see just in these numbers that on March the 30th, it was a sunny day. We had more than 20 megajoules. 2 days before that, it was very cloudy. On March 28th, we only had 4 megajoules in the entire day. The next two columns are really the results of the model, and they're the carbohydrate balance for that day. And generally, it's a negative balance if there is a deficit. And then the next column is what we call the 7-day weighted average or thinning index. And this considers the daily carbohydrate balance for 2 days before a spray, the day of spray, plus 4 days after the spray. It's a complex formula, weighting the day you spray and the next 2 days after you spray higher than the 2 days before spraying or the last 2 days in this formula. So once a chemical is applied, the hormone type chemicals, NAA, Maxell, those things, they're absorbed by the plant and they continue to act metabolically within the plant for 3 or 4 days after application. Therefore, the temperatures and sunlight for 3 to 4 days after application have an impact on thinning. Now, on the next slide, I'm going to scroll way down on that table, down into the thinning period. It starts on March 28th in that year, but now I'm down into May of 2021. Now, I said full bloom was on May 2nd. So once we get into bloom, then the model will start coloring the cells of both the carbohydrate columns into one of four colors, and they're listed here across the top. If you sprayed on that day, March 2nd, full bloom, and with these conditions before and after the spray, we would expect mild thinning, and hence they're all colored blue. And for this whole period, you see all the cells are colored blue. If they're colored green, we would expect good thinning. If they're colored orange, that'd be very, very good. But if they're colored red or pink, then you would have excessive thinning. But one of the most important things about this model is to avoid over-thinning events when thinning is going to be excessive and people don't realize it and they spray anyway. There is a degree day column that we added because of a long-term study we did of 17 years at Geneva. We found that the best thinning was always when degree days were between 200 and 250. The last column is this daily recommendation. If you happen to thin on that day, what Terrence Robinson would suggest you do as far as rate. I want to explain this just a little bit. We publish each year in what's called the Cornell Recommends for New York State a standard thinning rate for each variety. And so there's a different standard thinning rate for McIntosh than for Gala. What we're saying here in the model is that taking that standard rate on this particular day, if you thinned on May 2nd, you should increase the rate of chemical that you're applying because it's going to be very mild thinning and you won't get much out of just a standard rate. And we tell you to either increase a small amount or a large amount. The most we ever tell you to increase is about 30%. We have these little circles with a color in them. And these are whether there's low risk of overthinning or some caution, or there's a high risk of overthinning. And so you see during these days right after bloom, there was always a low risk of overthinning. Now, how do we use it? We try to time each one of the 3 post-bloom sprays based upon temperature degree days after bloom. So in recent years, we've been telling people, watch the carbon balance model, run it every day. When you get close to the 110 degree days after bloom, try to find a day to apply your petal fall spray. About a week later, it turns out, we generally get into the 200 to 250 degree days, and that's when we would try to find the best day in which to apply the 10 millimeter, 13 millimeter spray. And then if we need thinning, more thinning, we would put on a last spray between 300 and 350 degree days after bloom. Now, let me show you how this worked in practice. These are 3 locations in New York. Hudson Valley was where Milton is. Williamson is in Western New York. And then Peru is in the Champlain Valley. And I put down graphs from the carbohydrate model along with blue boxes showing the 3 different post-bloom thinning windows. The vertical line here at the beginning shows when full bloom was. You can tell that the time from full bloom to when the petal fall window opened, 110 to 130 degree days in the Hudson Valley was relatively short. In Western New York, it was even shorter. And in the Champlain Valley, it was just about the same as in the Hudson Valley. The main point I want to emphasize is the number of days in each window varies with how cold or warm it is. In the Hudson Valley, the petal fall window was quite long, about 5 days long, because it was cool. And you can tell the carbon balance was positive. That's what happens under cool weather. But you can tell when they got to the normal thinning spray of 10 to 13 millimeters, the window was very short. It was only 3 days long. And you had to pick a day in those 3 days to spray. Whereas 18 millimeters, it was a little bit longer. The exact opposite happened in Western New York. When they got to petal fall in Western New York last year, it was hot. And so the petal fall window was only 3 days long. But then by the time we got to 10 millimeters, it was cooler. And so we had about a 6-day window on which to choose the best day to apply our 10 millimeter spray. But when we got to the 18 millimeters, it was warm again and much shorter. And you can see that each one of the 3 regions had a different number of days in each window because we're working off of degree days. Now, the carbohydrate model will help you understand that by this column of accumulated degree days. We put into the model this black box that surrounds the degree days when we're in the prime window between 200 and 250. On May the 26th, they accumulated 200 degree days since bloom, and we would have said that's the first day you could put on your 10 millimeter to 12 millimeter spray. And then you have 1, 2, 3, 4, 5, 6 days before the degree days accumulate past 250 in which to apply your spray. So within those 6 days, you would tend to look at days without rain, days without temperatures in the 90s. And so you'd come over here and you'd look, well, on May 26th, they had a 90 degree temperature. I probably would avoid that day. But then I've got relatively cool temperatures, and the last day is a 75. So probably pick one of these days, either the last May 30th or May 31st, to put on that 10 millimeter spray, assuming it wasn't too windy. So you have to battle all of those factors, watching temperatures, watching rainfall, watching wind speed, but hopefully you can find one of those 6 days on which to apply your thinning spray. And this is the way we used the data last year in some of our thinning meetings. This is a slide that I pulled from a presentation I gave for a 10 millimeter type spray. And I looked at that chart on the previous slide, and I told people, you have basically between May 26th and May 31st to apply your 10 to 13 millimeter spray. I suggested that any one of those 6 days would give relatively mild thinning. Now, how did we know that? Well, we get that over here from the color of the boxes. Now, you can tell that it's mild thinning from the blue color of the box. A little previous to that, it was green, but during the period of time that we're going to be suggesting they thin, it was all relatively mild thinning. The temperatures were only going to rise up into the 60s and mid 70s by the end of that 6 day window. But the big problem was that the carbohydrate balance is generally positive, and that's where we see this upper thing up here. Through this whole window of the optimum thinning period, the carbohydrate balance was positive, indicating we wouldn't get very aggressive thinning. So I said the carbohydrate surplus and cool temperatures will give mild thinning. Therefore, use full rates. What did the model suggest? It said to increase rates by 30% for every one of those days if you were going to thin then. But I also indicated that because of the cool temperatures, even with increased rates, it was unlikely that that particular spray would give enough thinning. So we would probably be forced to come back with a rescue spray at 18 millimeters. All of this depends on the temperatures and the sunlight that you happen to get when you enter these various thinning windows. So we know, or we can predict at least somewhat, what we think is going to happen when we spray at either petal fall, or we spray at 10 millimeters or at 18 millimeters. Therefore, the development of this fruit growth rate model that Dwayne Green developed, and primarily Alan Laxo and myself to a little bit, has been an invaluable resource in helping us understand what happened once we spray and whether we should spray again. If you wait to look at that visually, it takes about 2 weeks from any spray to really see how many apples have fallen or will fall. You wait for their stems to yellow up, and then you look at how many are falling. But often we need to make a decision on whether to respray in only 1 week's time. The model will predict what percentage of the fruits on the tree will drop and what percent will persist. It requires the grower to physically count the total number of flowers clusters on each of 5 trees. And we have this rule that we do not count bloom on 1 year wood. So I wanted to comment, Mike's results show that often this model overestimated how much thinning, because sometimes those fruits on 1 year wood continue to hang on. We try to thin them all off, but if some of them hang on, we end up with more fruits than what the model estimates that we would have. Once you make those initial counts of the entire tree, then we tag 15 spurs on each of those trees, and then after we sprayed, wait till 50 degree days have elapsed. We measure every one of those fruitlets in any order on 15 tag spurs on 5 trees, which totals to 375 measurements. And then we wait till 100 degree days after application and remeasure again. And based on that, we calculate the percent of persisting fruits. Now, there's simplifications that we've done to this model. The first is that we discarded the need to keep track of the order of fruitlets within each cluster. So now we just measure them in any order, and behind the scenes, we rank them within the cluster from the biggest to the smallest each time to run the model. The second thing we've done is develop this degree day way to decide when to make the first measurement and when to make the second measurement. So we suggest that you wait till 50 degree days have elapsed after the spray and make your first measurement. And then wait till 100 degree days after application to make the second measurement. And then the last thing we've done is if you use the phone app version, the Malusim version, we've included error detection protocols to eliminate an error in typing in the data or error in measurement that gives excessively large growth rates, and that will overestimate how much thinning you did. Now, going back to this output of the NEWA model, let's suppose you chose to spray on this day, on May 26th, when you had exactly 200 degree days from bloom, and it's a good timing. We would then wait till 50 more degree days have accumulated till we got to 250 and then make our first measurement. Now, because it's so cool, after application, it's 1, 2, 3, 4, 5 days before we measure. But by using the 50 degree days to time your first measurement, you will get the proper timing, and then you wait till 100 have passed before you make the second measurement. Now, I want to spend just a few minutes talking about the Malusim version of the fruit growth rate model. When you download the app and you open it up, one of the first things it will ask you to do is to put in the base numbers for the block you're trying to predict thinning. And so you have to choose how many trees you're going to be measuring, how many clusters. The typical recommendation is 5 trees, 15 clusters per tree. And then there's generally 5 fruitlets in each cluster. That told you add, multiply that out, and it's 375 fruits. Then we said you had to count the total number of flower clusters on each of 5 trees. And in this particular case, they varied from as low as 58 on tree 2 to 101 on tree 3, and the average was 75. So 75 average flower clusters times 5 gives you that tree had a potential of 376 fruits, but the grower has decided he only needs 85 fruits to have a full crop. Then you go out and you measure. And here you can see is the way the data is entered on this. You can enter it on your phone out in the field while you're measuring. It has across the top tree 1, 2, 3, 4, and 5. And then when you select on each tree, it has cluster 1, 2, 3, 4 through cluster 15. And this is the second measurement. And it says when you measured the first time, there was only 3 fruitlets in cluster 1. There was 4 in cluster 2. There's 4, 4, 4, and 3 and 4. And so it automatically will pre-populate all the fruitlets with how many it was before. And then you enter the new number as you measure it. If you don't like it, you can clear all the measurements, but this is the way you enter it. There's also a phone recognition piece to this. If you want to just say the number, it should recognize it, but you have to double check that it correctly can understand what you said and it put it in the right cell. But once you do that, then the model will run and you end up with this sort of a output. I just put in here, this was a Honeycrisp block from 2021. The grower wanted 85 fruits and measured the first time on June 1st, the second time on June 4th. So only 3 days between measurements. On June 1st, the average size was 6.3, and on June 4th, it was 8.4. Based on all the fruitlets measured, it already calculated that from the 376 original fruits that are on the tree, that petal fall spray knocked off most of them, and there was only 109 left, and the target was 85. So we got very close to the target in just one spray. Why was that? Because in Western New York, it was warm at petal fall. And in fact, almost all the thinning in Western New York came from the petal fall sprays last year. At 10 millimeters, it was much cooler, and we got very little thinning. And that's the value of using both a carbohydrate model and this Malusim fruit growth rate model. So in this case, I told the grower, stop. You've got a few more fruits than you want, but if you thin again, you might overthin. So best to hand thin off about 24 fruits per tree. There also is a button here where you want to see view model data. If you click that button, it will bring up this table that I have pasted in the bottom here. For each one of the 2 dates of measurement, June 1st and 4th, it'll show you the diameter of the largest fruits. It was 10 millimeters of the largest fruits, whereas the mean was only 6. But then at the second time, the biggest fruits were 14, and the average of all was 8. So these biggest fruits are the ones that grow fastest. And then it shows you that the biggest fruits grew 4 millimeters over those 3 days. And so half of that is 2 millimeters. And then it tells you how many are going to drop off and the predicted fruit set. Graphically, it shows you the same up there. The Malusim model, whether it's the NEWA version or the Malusim FONAP version, is essential to predict thinning efficacy before you put the chemical in the tank. And it's also extremely useful to warn you when there will be excessive thinning and over thinning, and then you avoid thinning on those days. It's easy to use and should be run on a daily basis during the thinning season. The fruit growth rate model, I think, is a wonderful tool to determine what happened after you put the thinning spray on to allow a more informed decision on the next thinning spray. It's not available on NEWA, this fruit growth rate model. It's either on the phone app or at malusim.org, but it's still even tedious because it requires manual measurements of fruit diameter. But I'm excited that improved methods to get that fruit diameter measurement and then plug into the model are on the way, and they're going to make use of fruit growth rate model much less tedious. Return bloom of Honeycrisp requires a real effort. And this is the program we're suggesting this year. Spray with ATS, then spray with 2 sprays of NA and get your thinning done at petal fall on 12 millimeters. But then we're suggesting you start with a series of ethereal sprays earlier than what we previously suggested. The first one at 16 millimeters at half rate, that's half pint per acre. But then 3 more every week after that at a full pint of ethereal per acre. If you did a good job of pruning and then a good job of bloom thinning and petal fall on 12 millimeters, and you can get the seed number down to a reasonable number, which is 1,000 to 1,500 seeds per tree, that's 100 to 150 fruits per tree, then these return bloom sprays will work.